Hello, welcome to part 2 of my coding challenge, Quadtrees. So what I want to do in this part is I want to look at how I can retrieve a list of points from a given area without having, and this is going to, I don't have to, like I could say like this boundary over here, give me all the points in that area. Well, I can just look through every point and see if they're contained within that boundary. But the Quadtree is going to allow me to do that more efficiently by kind of looking at the sections that are near this particular range that I'm going to create. Oh, boy, am I not explaining this well. Let me explain this visually. So what I'm going to do, let me just draw a rectangle. Let me say something like stroke 0, 255, 0. Let me draw a rectangle, and I think because I'm going to say rect mode center, and I'm going to draw a rectangle that's, how big is the canvas? 400, 400. So I'm going to go over to like 300, down to like 300, and I'm going to say 100, comma 50. So, and this is way too exact. Like, so let's say 107 and like 92. Okay. So, and I don't know why it's really bothering me that, there, okay. So basically what I want is I just want the points, and there's not a lot of points there, so let me move this over. I'm really wasting so much time on this. Perfect, this is what I want. What I want now is to say like, just give me all the points that are in this area. But I want to ask the Quadtree for it, because the Quadtree is going to have the capability of giving me those points more efficiently. It's not going to have to check every single point. So let's see if I can do that. So in order to do this, what I need is in the Quadtree, I need a new function. And I'm going to call it query. And let me put it above show. Show is just sort of a drawing stuff, which is really just for debugging at this point. I'm going to write a function called query, and it's going to take as an argument a range. And what that range is, it's essentially a boundary. I don't want to use the word boundary because it's going to get confusing, because the Quadtree object itself has a this.boundary. So the first thing I need to do is I just need to, I need to say, does this range and this Quadtree, do they overlap? If they do, then there might be some points that I want to give you. If not, it can be ignored. And if it can be ignored, that means I don't have to check any of the points that are in it or any of its nested subsections. So that's the first thing I need to say is say if this dot boundary dot intersects range. If it does not intersect the range, let's just get out of here. I'm done. I don't need to look. I don't need to look away. I don't need to look any further. I'm done. I'm going to have to change this in a little bit, but this should work. Now, here's the thing. If I'm saying if this dot boundary intersects, well, I've kind of got a bit of a problem here, which is that the boundary is a rectangle object, and I don't see an intersects function. But guess what? I can write one. So, oops, idea. I'm going to write an intersects function. Intersects another, I'm going to say range. Why not range? So there was another coding challenge where I had to do this. I can't remember what it was. It was one of my early coding challenges where I had to test, do two rectangles overlap or do they not overlap? And I think there's a nice way of doing this with an or, basically saying, hey, if any of these conditions are true, they can't possibly be overlapping. For example, if the x of this one is greater than, well, if this edge is greater than that edge, or if this edge is less than that edge, or if this edge is greater than that edge, or if this edge is less than that edge, if this is anywhere outside, then they are not intersecting. This is going to be so painful to write. There's got to be a really easy way to write this. Okay, so let's think about this. If range.x minus range.w is greater than, right? So if this is the rectangle range and this is its left edge is greater than this right edge. Actually, this isn't going to be so bad. Is greater than this dot x plus this dot w, or, right, range dot x plus this dot w is less than this dot x minus this dot w, or, I think I can do this now with the y's. Range dot y, h y, h, h, y, h. This is really, you're watching a person here type this stuff. H. All right. So, and I want to return this, not if. I want to return. So if they intersect, if this is true, they don't intersect. So I want to return not this whole expression. All right, nobody can seem to tell me that I'm wrong. I stared at it enough time. I'm going to move on. Also, it was pointed out, it was the Frogger coding challenge where I struggled through this for a very, very long time. So I could go back and check my Frogger code, and I probably could also use somebody else's library that has like geometry math in it, but let's move on. Okay, so now, if this should work. Now, what if they do intersect? If they do intersect, here's what I need to do actually. So I need to recursively go through everything. And I'm going to say, I want to have I'm going to create a variable called found. So I want to find all of the points. So if they don't intersect, return found, it'll be an empty array. So this will be an empty array. Otherwise, now, if they do intersect, let me look through all the points that are part of this quad tree and say if range.contains p found.push p. So now I know that the boundary and the range, that this quad tree intersects that range. So let me check all its points and see if they're within the range, then I can add them. Perfect, I've added them. And now what I need to do though is say if this dot divided, then, okay, well, basically what I want to do is I'm going to return, so then I should return those points, right? But before I return those points, what do I need to do? Well, if it has some children, quadtrees, then I need to check if any of those points are in there. So what I need to do is say if it's divided. So if it's not divided, I can ignore this. I can say return this dot northwest query range. Okay, I know it's going to be easier here, right? I could pass the array and keep adding to that array reference, which is I think what you would normally do with recursion. But for some reason, the way that I'm thinking about this right now is I can say found.concat this dot northwest query range. And then I can say northeast, southwest, southeast. What this is going to do, and then I can return found here. So what I can do is, right, I'm going to start with an empty array. If it doesn't intersect, just return an empty array, and all this concat stuff is going to concatenate. Concatenate should just join two arrays together. So what I need to do is, if there's nothing here, move along, return nothing. Otherwise, if there is something here, check my points to see which ones I should add. Then if I've divided, I should also add any of the points that are from my children. And then when I'm all done finally, I'm going to return that array. I think this is good. I'm sure something's wrong here. I'm going to get rid of all these extra line breaks that I don't need anymore. And now, here I should have, okay, so I have this rectangle, but this is actually, I need to say a range is, and I really should make this, let range be a new rectangle that is 250, 250, 107, 75. And I'm going to divide those by whatever, that's fine. I'll make it bigger. And then I'm going to draw the rectangle at range.x, range.y, range.w times 2, range.h times 2. So let me just take a look at this. W is not defined. Whoops, times 2. All right, so I just made it a little bit bigger. So now what I want to do is I want to say, oh boy, let points equal qutree.query range. And just to see, let me console.log that array. Without even trying to draw stuff, let me just see if this function even returns anything. It gave me 3 points. Okay, so this can't possibly be right. I've done something wrong, which is that I only got 3 points. So a bunch of people in the chat, I can't credit everybody telling me the concat method is used to merge 2 or more arrays. The method does not change the existing array, but instead returns a new array. This is from Pierre in the chat. So what the issue there is, and maybe now I kind of don't want to use this concat, because I have to write this, right? I have to say, I think passing the array is going to be better. So apologies. I'm going to say return. I kind of like passing the array better. So query range array. If no array, then I'll call this found. Then found is a blank array. So I create the array if it doesn't exist. Then I can just return the empty array. Then I can push the stuff here. And then now I can get rid of this crazy. This concatenating idea was very silly. I don't know who thought of this. And whoa, I've got extra parentheses like mad here. Now I can say with the array, and I can just pass the array. So I'm just going to pass the array around, and I actually don't even need to, I do want to return found when I get, because now I want to return it, but I only want to return it at the end of the very first. So I think, let me do it this way. There's got to be a better way for this, but let me just, to get this work, let me pass in an array. I'm going to think about how to return it better in a second, but let me create an empty array and then pass it in, and then we'll look at that array. So, okay. This just gets me out of here, et cetera, et cetera, et cetera. Okay. Here we go. All right, 160. That makes a little bit more sense. There could be 160 points in there. So let me now, in the sketch, let me say for let p of points, and then stroke 0 to 55, 0. I guess I already have that. Let me draw the points. And let me say point p.x, p.y. So let's look and see if that worked. Hey, this is looking pretty good. Pretty good. All right, let's make this rectangular range random. So let's pick a random point, a random height, and let's give it some random width within 100. Actually, let's just always make it 100, 100. And let's see what happens. All right. So wherever, wait. Why are there some points here not showing up? Something is wrong. Guess what? Remember this function that I spent like an hour staring at? Apparently, I was looking at the chat the whole time. There's a significant error in here that I have mixed up. Oh yeah, look at that. Range.x plus this.w. Ooh. Range.w. Range.h. Range. This. I got to stare at that for a little more time. All right, so I think that's corrected it. We'll find out. I can't find any points. Oh, look at that. Look at that beautiful. I found all the points within that region. Now, just out of curiosity, I just want to check something for myself. If there are 300 points, so if I create I'm just going to create a global variable called count, right? And if I were to check every single point, I would if I would look through every single point to see if it's within that range, count plus plus, count would equal 300. But I am going to here, just as a little sort of like hack check, is I am going to increase the count here. And I shouldn't have to look at all 300 points. I should be looking at a subset of points. So let me console log that count. 31, 27, 48, 219. Now, of course, I've got to look at a lot with this big range because I kind of got picked randomly through the center. But I never have to look through all the points. And so this algorithm, if I make the range the whole canvas, well, then I have to look through all the points. The point is, if my range is something much smaller, like even if it's like 25 by 25, right? I only have to do very, very few checks, even if it's randomly in the center. And let's get rid of this count idea, because I don't need that count idea anymore. Let's go. This is going to be fun. Oh, so much fun. Let's go put this in draw. And let's make the rectangle mouse x, mouse y. Count is not defined where at draw sketch.js line 26. Oh, Quadtree line 87, sorry. Quadtree line 87, save. So now you can see, as I move the rectangle, it is highlighting only the points that it finds. I kind of want the count back. Because I kind of want to know how many checks, but this is great. All right, woohoo! I think I've successfully now implemented the full Quadtree because I have both an insert function and a query function. Let's quickly go to that Wikipedia page. And if we look at the pseudocode, right, we can sort of match this up with what we did. There's this idea of a point, an xy, an AABB, which is my rectangle, an axis-aligned boundary box. There's the Quadtree class. It has a capacity, it has a boundary, northwest, north, all of those things. We have an insert, subdivide, and query range, right? Query, insert. Yeah. So I think that I have basically done everything. And probably, I did read this Wikipedia page the other day, and that's why I think I started using concat, because it's using append. So, but I think I like my, so here's the thing. I really should this video should be over because it's taking way too long. But I do kind of I really sort of want this. Oh, I know what I can do. I want to return the points array. Let me fix it so it returns the points array. Let points equals query that range. So I really just want to get an array back. So now if I go in here, so if found does not exist, found should equal an empty array. And then can I just say return found down here? Is that going to work? That works. I don't know why I thought it was so complicated. The reason why I kind of was afraid to do that is that these are also returning the reference to the array, but it doesn't matter because I'm not doing anything with it. So that's fine. So the only return that really counts is the very, very, very last one, which is the original call to the query function. So now, okay, that was much easier than I thought. So now at least I have the function return that array. Okay, I'm going to be done. There's one more video I need to make. And I think, though, there's many more videos I need to make. But part 3, it's going to come later. Hopefully by the time you watch this, it might actually be linked to, but what that video is going to do is I want to apply the Quadtree algorithm to a collision detection problem. And in particular, a really good one for me to apply it to, it's not really collision detection, is my flocking simulation. I also would like to port this to processing and make a Java version of this. So those are all the things that I want to do. But if you're watching this video right now and the next one isn't available, as a challenge to yourself, see if you can take this and apply it to a collision detection problem. And then I'll be back and doing that myself someday. And that's what's going to happen. Okay? Thank you, everybody.